Welcome back to the channel for practice problems for actuarial exams. You can find that channel on YouTube by going to smarturl.it/pass actuarial exams. And you can find information about me by going to smarturl.it/Jedi. If you would like to help actuarial students at Illinois State University, where I direct the actuarial program, please go to smarturl.it/ISU actuary donate. Here's our problem. This is the last multiple choice problem from the last spring 2017 exam MLC, problem number 20 in multiple choice section. On January 1st, 2017, Lewis is a 51-year-old member of a defined benefit pension plan. Lewis has 10 years of past service, and his salary for 2017 is $70,400. You are given the annual retirement benefit is 2% of the final year's salary for each year of service, and there are no death benefits. His salary for 2016 was $68,700. The pension is payable as a monthly single life annuity due upon retirement. His normal retirement date is December 31, 2030, at age 65. There are no decrements other than death prior to retirement. Mortality follows the illustrative life table. Interest rate is 6%. A.65 upper 12 is 9.4316. This is the present value of the annuity that represents the way the benefit is paid, so it's a number that is useful for the calculation. Calculate the normal contribution at January 1st, 2017 under the traditional unit credit cost method. So let's recall that normal contribution is the strange name for normal cost in the book that is the textbook for the exam. And we are looking at the normal cost for 2017 as of the beginning of the year 2017, and we're using the traditional unit credit method. The essential thing about the approach of the textbook to this pension funding approach, the pension funding for the methods that they consider is that they use a version of the recursive reserve formula, which is the same idea as the recursive asset share formula. So you can write it as the accrued liability, or it's like reserve, TV, plus the premium, which is the normal contribution, CT, is equal to the expected present value of benefits for mid-year exits, assuming only mid-year exits, plus present value of the accrued liabilities for those who survive till the end of the year. That's one way of writing this, or you can just figure out what the normal cost or normal contribution is based on that. It's going to be equal to that final reserve. Of course, it's discounted to the beginning of the year. We're doing the calculation of the normal cost at the beginning of the year anyway, so that's why the reserve or accrued liability should be discounted to the beginning of the year, and of course only existing for those who survive. That's why we have this X years old staying in state 0, being the state of being a active plan participant over 1 year. Plus it has to pay for the cost of the mid-year exits, which we figure out by taking their actuarial present value, expected present value at the beginning of the year, and minus the initial accrued liability. So in this case, the expected present value of mid-year exits is 0, as we are told that there are no decrements other than death prior to retirement, and there are no death benefits. So participants may exit as accounted for in the probability of survival, but there are no payments upon those exits, so zero expected present value. Now they may exit by dying, but still that gives zero value in this case. So the recursive formula becomes, as of the beginning of the year 2017, the normal cost for normal contribution for the year 2017 is the actuarial present value of the accrued liability at the end of the year minus the accrued liability at the beginning of the year. And these liabilities are calculated well, for 2016 as the end of the year 2016, which is effectively the same as the beginning of 2017. And for 2017, it's for the end of the year 2017. And what are they? Well, for 2017, this person will have 10 years of service. The salary in 2016 is $68,700. Now you may complain, well, but that's not the final salary. This is the traditional unit credit method. We do not project the salary. That's why we use the salary from that year. Times 2%. And for 2% of the salary, because the salary is not projected. It's traditional unit credit. Times the annuity factor. And then we have to discount all this back actuarially, so with the pure endowment factor, back 14 years. And for 2017, there's 11 years of service. Salary is $70,400, 2% of the salary for each year of service. Annuity factor, and then we discount this 13 years back. So we combine these two things that we just calculated, and we write it in. And then we have this 13-year pure endowment factor and a 14-year. So we rewrite the 14-year as 1.06 to the negative 1 times the probability of survival for 51-year-old. And then the rest is exactly that 13-year thing that we have in the other one. And then we try to combine the like terms. So So we realize that that term 1.06 to the negative 1 times P51, that if multiplied by 13E52 gives us 14E51, well, that is actually at the beginning of the first expression that we have there. So we really have 14E51 in both of them, and we have the annuity factor in both of them. So we put them at the end, and then everything else we put in the parentheses. And the thing in parentheses can be calculated pretty quickly. The annuity factor is known, and the only thing that we need to figure out is this 14E51. Well, it can be figured out from the illustrative life table because 10E51 is in the table. It's equal to 0.50678. And 5E61 is in the table, but when we multiply the 10-year factor by the 5-year factor, that's a 15-year, and we have 14 here. So we have to divide it by 1.06 to the negative 1 times P65 to make it equivalent. And that number P65 is also in the table. It's actually Q65, which is 21.32 per thousand. So we use all this information from the illustrative life table. We plug in the numbers, and we have the answer, 6174.20, which is answer A. So the crucial insight of this is that the textbook for the exam uses this standard reserve recursive formula for figuring out the normal contribution or normal cost. And they don't normally do this in pension textbooks, but nothing unusual about it, and it's kind of good for you to see the equivalence, in a sense, between pension funding and life insurance. So that's a healthy exercise. Good for you. Please remember this is copyrighted material. And of course, Society of Actuaries problem from the recent exam, so the problem itself belongs to the Society of Actuaries, while the solution is mine. Good luck in your studies and good luck on the test.